So let's start with section 2.3, which is we're going to do the same thing using the limits. Here we go. The first rules. Every time when they ask you find the limit for a constant. Constant, let's mean a number. 3, 4, 5, 6. Every time when you need to find the limit for constant, the result is going to be the constant number, okay? Every time when you need to find the limit for x, that means you're going to plug in a where? In the x. These 3 and 4, it's really important because there is a relationship between these and the nodes. It's easier to find the limit. I'm gonna check that. But every time the limit, when x approaches to the 0 from the right side, 1 over x, the limit is going to be inverted, going up, which is look like this. That means 0 is an asymptote. So the limit every time when it approaches to the 0 from, let's say from the right side, it's going to go up. If it's from the left side, which is 0 from the left side, the limit also is going to go up because 0 is a vertical asymptote. How are we going to know it's a vertical asymptote? Because when you plug in 0 here, 1 divided by 0 is going to be undefined, okay? That means the function is undefined when x equals 0. That means the asymptote. We're going to check that on the note. Now, when the limit, this one is supposed to, oh yeah, it's supposed to be going down, not up. So this one is going to be positive infinity. And when the limit approaches to the 0 from the left side, 1 over x is going to be going down. So, and the left side is going to go down, from the right side is going to go up. The properties of limits. Every time when you have limit, the addition or minus of 2 functions is going to be the limit for the first one plus or minus the limit for the second one. Okay? Yeah, you're going to take the limits for each one. It's exactly like the polynomial. The limit when x approaches to the multiplication of 2 functions, let's say 3x, which is 3 times x. So that means it's going to be the limit for the 3 and the limit for the x. The limit for the first function times the limit for the second function. The same thing with the division is going to be the limit for. In fact, we're not going to use this rule because you're just going to find the limit right away. But that's how it's worked, okay? The limit, the division of 2 polynomial, let's say, is going to be the limit for the top, the limit of the bottom, but there's a condition. Always the limit for g of x is supposed to be not equal
0.
because it's going to be undefined if it's equal to the 0. This is important. The limit of a function with the power. How are we going to find that? You're just going to take the limit for the function and put the power outside. This is really important. Okay? And now this, well, number to the next one. Limits of track functions. These look like rules. We're going to use it when we solve the examples. Always the limit when x approaches to the 0, be careful, it's a 0. Sine x over x, how much is going to be the result? 1. There's a proof for this one. We're not going to check the proof because it takes a long time. But if you want to check it, you're just going to check the book or the slides. There's a proof for this one. But we're just going to use the rule. Limit when x approaches 0, 1 minus cosine x over x is going to be 0. And the limit 1 plus x to the power 1 over x, the limit is going to be the exponential function. Just the e, which is look like a number. Okay. And the next part, I told you the limit when approach to a certain function, I'm supposed to be here infinity with the infinity. The limit for the function approach to the number a from the right side, gonna go where? To the infinity. Any number here on the right, here or here. I'm just gonna take this one as an asymptote, okay? Could be the asymptote on this side, it doesn't matter. But if the limit approach to a certain number from the right side, always gonna go where? Up. The limit of approach to the same number, see, I'm just gonna take the same number here, approach from the left side. This is the left side. Oh, also from the left side. There's something wrong with this one, right? On the right side, always. Also, but this one is gonna go where? Could be up, could be down. Number 3, the limit approach from the left side for the asymptote could be goes where? Up, or goes where? Down. In this case, how are we gonna check that? How are you gonna check that the limit is gonna up or down? By evaluating. You're gonna pick a number from this side. I'm gonna pick a number from this side and plug in my function. Because you have a function, if it's negative, that's mean going where? That's talking about this one. You're gonna pick number from this side. If it's negative, that's mean the function going where? Down. If it's positive, that's mean the function going where? Up. If you pick a number from the right side and the result is going to be positive, that's mean the function going where? Up. If it's negative, that's mean the function going where? Down. Okay? So you're gonna pick a number, plug it in the function to check the function going up or down, which is positive or negative. Okay? And check some notes. Find the limit when x approaches to the 2 to x squared plus a 3x plus 7. To find the limit, it's a polynomial. That means it's going to be, let's do it as a math way, which is in fact is the limit for x approaches to the 2 to the x squared plus the limit when x approaches to the 2 to the 3x plus the limit when x approaches to the 2 to the 7. Because we already have rule number 1, the limit for a polynomial for 2 functions, add or minus, is going to be the limit for the first one plus the limit for the second one, right? Plus the limit for the third one. I'm using rule number 1. The limit for addition or minus, which is going to be the limit for the first function, the limit for the second one, the limit for the third one. This is multiplication, right? Of course, you're not going to do these steps, but that's how it's the math, okay? So it's going to be the limit for x approach to the 2 to the x squared plus the limit for x approach to the 2 to the 3 times the limit when x approach to the 2 to the x plus the limit x approach to the 2 to the 7. Because these are multiplications, so it'll give you limit the first one, limit the second one. Now, the limit for x, you're just gonna plug in the number here, yes or no? So it's gonna be 2 squared plus the limit for constant is constant, that's me here, it's the 3. The limit for x, plug in the 2 here, so it's going to be times 2. The limit for constant is going to be constant, so plus 7. Then it's going to be 4 plus 6 plus 7, and how much the result? 17. So you see these steps, this is how it's worked by using this rule. But we're not gonna do that, you're just gonna hide away, you're gonna say, okay, it's a polynomial. it's a polynomial. That's mean I can evaluate by plugging 2 here. So if you plug in 2, right away is going to be 2 squared plus b times 2 plus 7. How much the result? Here is 4 plus 6 plus 7, and the result is going to be 17, which is exactly what we got here. As a math, this is how it's worked by using the same rule. But here's the shortcut. You're just gonna plug in the number and you can get the result. Okay? Find the limit for polynomial. Just gonna plug in. Find the limit for x approaches to the 2, x to the power 4. I'm gonna ask you, this is f of x. Is that polynomial? X to the power 4, is that polynomial? Yes or no? It's a polynomial. X to the power 4, it's polynomial, which is the same thing. It's x to the power 4 plus 0x cubed plus 0x squared plus 0x plus 0. Can you write down this exactly the same thing? Because this is still 0, this is 0, this is 0, this is 0. So any number, any variable with positive power is polynomial. Okay, so keep this note in your mind. Any variable with positive number, it's a polynomial. What about this one? Is that polynomial? No, it's not polynomial. Okay. And don't worry about the coefficient. If there's coefficient, don't look at the coefficient. The main thing, it's a number, variable, positive exponents. If it's one term, it's going to be monomial. If it's 2 terms, it's called binomial. 3 terms, monomial. 4 terms, just call it polynomial and keep going. So it's polynomial. Because you're going to plug in 2 here. That means 2 to the power 4, and the result is going to be 16. I'm trying to. Now, if you look at this example, I'm going to ask you, is that polynomial?
Yes.
But it's irrational. That means the top part is polynomial and the bottom part is polynomial, right? So to solve it, can I use rule number 3? I need to find the limit for 2 functions. F of x divided by g of x is going to be the same thing, finding the limit when x like finding the limit x approach to the 2 or x squared plus 1 divided by the limit when x approach to the 2 to the x minus 3. So just like first time writing. Find the limit for the top and find the limit for the bottom, right? So the top, is that polynomial?
Yes.
That means just gonna plug in 4 2 squared plus 1 divide. Is that polynomial? Is that polynomial? Yes, it's polynomial. So you're gonna plug in, it's going to be 2 minus 3. And that means 4 times 4 is going to be 16 plus 1, 17 over negative 1, and now it's negative 7. Come on, is that hard? You're not gonna do the rules on the test. If you just plug in, if you write down this, it's gonna be fine. If you just plug in, I'm not gonna say it's wrong, because that's right. Polynomial, plug in the number, that's it. No, it's going to be negative 17. Okay. Because now we're going to use it. The notice says if you evaluate the polynomial and your result from the top is 0 and from the bottom is 0, what do you have to do?
Factor and simplify.
Factor and simplify. That means you can't just evaluate and the result is not going to be 0. Now let's check this example. Because it's polynomial on the top and polynomial on the bottom. So you said, okay, I'm just gonna plug in the number and get the result. So if you plug in 2 here, is going to be 2 squared minus 4, which is equal 0. Plug in the 2 here, 2 minus 2, and also the result is going to be 0. Again, if it's 0 over a number, that means the result is going to be 0. If it's a number divided by the 0, it's going to be undefined. That means the limit does not exist. Write down these notes. If it's 0 divided by a number, it's going to be the result 0. If it's a number divided by 0, it's going to be undefined. That means the limit does not exist. If it's 0 by 0, what do you have to do? Factor and simplify. So let's check here. I'm going to go back here. Can I factor the top part? Yes or no? I'm going to open 2 parentheses. Is difference between 2 squares. I'm going to put 1x here, 1x here. 4, which is 2 times 2. 1 plus, 1 minus. And I'm not going to factor this one because you can't factor it.
Okay.
Simplify, yes. We're going to talk about this one when we finish the example. Now, the result is going to be what? It's the limit when x approaches to the 2,
4.
just x plus 2. And then you're going to plug in 2 plus 2. And the result is 4. My question. X plus 2, this is our function now because we simplify. X minus 2 is what? Go ahead and graph this function. Graph this one and tell me x minus 2 is what? So this is important again. Every time when 0 divided by 0, when you evaluate the 2 and the result is 0 over 0, you have to factor and simplify. And then just plug in the number, you get 4. The one you're gonna cancel, it's a hole on the graph, okay? If it's 0 divided by a number, that means the result is going to be 0. You don't have to factor and simplify. If it's a number divided by 0, it's undefined. That means the function does not, the limit does not exist. If it's 0 by 0, that means you have to factor and simplify. We're gonna do the same thing. So you can say, okay, I have polynomial on the top and polynomial on the bottom, right? So my way to solve it, I'm just gonna plug in the number. So if I plug in 5 here, it's going to be 25 minus, plug in the 5 here, which is 25. 3 times 5 is 15 minus 10. The result on the top is 0. Now, 25 here minus 10 times 5 plus the 25. This is 50. 25 plus 25 is 50, so the result is 0. 0 divided by 0, that's mean you're going to factor and simplify. Okay, let's factor this one. So this one is going to be the same thing, the limit when x approach to the 5. Open 2 parentheses. Here's 2 parentheses. I'm going to put x here, x here. Now 10, 2 times 5 is going to be 10. I need to get, so I'm gonna put 2 here and 5 here. I need to get negative 3. So here is negative and here is positive. You have a problem with factoring? It's easy. That's important. The same thing here. I'm 25, I need to get 10. Here is x, here is x. I'm gonna use 5 times 5. I need to get negative 10, so minus. Can we simplify it? Check here. If I cancel this one with this one, that means x minus 5 equals 0. So x equals 5 is what on the graph?
What we were talking about?
It's a hole on the graph, okay? That means the function is not continuous at this point, okay? I'm gonna ask you now. Look here. What about x minus 5? This one, the other one. It's a hole on the graph, but on the same time is what? It's what? It's a rational function. So when you graph it at x equal 5, you said it's a hole, right? 1, 2, 3, 4, 5. It's what?
Asymptote?
It's an asymptote. Of course, on the asymptote, the function is not gonna continuous because the function is never going to cross this vertical asymptote. Okay, so it's a hole, right? But it's an asymptote. So you don't have to worry about it's a hole or no. It's an asymptote on the graph because of course the function is going to be undefined at when x equals 5. Okay, this is like just to refresh your memory because it's the same connection. Now, when x approaches to this number from both sides, I need to find the limit. Now it's a polynomial. Can I plug in the number? So it's going to be 5 plus 2 over what? Can you?
And over 0? That'd
Zero,
be
zero.
fine.
That means 5 minus 5. So it's going to be, why it's not undefined? Have to look here. Because it's going to be 7 over 0, which is undefined. That means the limit
Not exist.
does not exist. That's how you're going to plug in an open sign. Does not exist. But let's look here. Because the limit approach to which number? To number 5. So that means from the left and from the right. Let's check from the right. When the limit approach to the 5 from the right side, go back here. From the right side, the limit goes where?
Infinity?
To infinity, okay. So that means from the right side, the limit goes here. From the left side, goes where? You can check, plug in the numbers. Take any x, so from the left side goes down. Take any x here, plug it in the function, is gonna go up. That means the result is gonna go to the infinity. Take any number here, plug it in the function, the result going where? Down. One function going up, one side going down. Does that mean the limit is what?
Does not exist.
Does not exist, okay? So if you say, okay, how am I gonna know the limit? With the graph, how am I gonna know it does not, with these steps, does not exist, because it's undefined. But here with the graph, one side going up, I'm gonna take any x here, plug it in the function, the result is gonna go, you see, going up. You're gonna take any number here, plug it in the function, the result going where? Down, one up, one down. The limit does not exist, okay? Take this one, limit when x minus 1, square root of x minus. Yes, okay, I'm gonna solve it. Can I evaluate?
So you can move the radical out from being a denominator? Or no?
But how? That's a good idea.
Square it off. Yeah.
You can't, because you're gonna say square both sides. Where is the other side? So you can do that. Wait. So now if you evaluate, then I'm plugging 1 minus 1 is going to be 0. Square root of 1 minus 1, so 0 over 0. So I have to factor and simplify. Can I factor it? No. In this case, you already, one of you said. Did you say something about how it's gonna, what?
Would it be the conjugate?
Which is mean,
So you get the difference, so.
which is rationalize. So every time when you see you can't factor it, that's mean I'm gonna think about rationalize, okay? And this is the first point. The second point, if you can't factor it, and when you plug in is going to be 0 and 0, think about the conjugate. And every time when you see a radical, the first idea is going to be in your mind, maybe I'm gonna use the conjugate, okay? Now I have square root, I'm gonna use the conjugate. I need to rationalize this part, so I'm gonna multiply by square root of x plus 1. Okay? Rationalize. Because the problem always is going to be with the bottom part. When you got 0, it's going to be undefined. That means this one is going to be equal the limit x minus 1. On the top part, I'm not going to care. I'm not going to distribute. I'm just going to say it's x minus 1 square root of x plus 1. Don't make it harder. You're going to distribute and then just keep it like this. Okay? Because when you plug in 1 minus 1, 1 plus 1 is going to still 0, right? 0 is not going to affect. If it's 0 over a number, it's going to be 0. The problem here on the bottom part, for 0 over 0, I have to factor. Number over 0 is going to be undefined. So now on the bottom part, square root of x times square root of x is going to be x. I'm distributing, okay? Square root of x minus 1. Square root of x plus 1. Square root of x times square root of x is going to be x. Square root of x times 1. Square root of x. Negative 1 times square root of x. Negative 1 times 1.
0? Oh, 1.
Times, yeah.
Negative 1.
So minus 1. These cancel. That means going to be the limit. X approach to the, this is approach.
That's the square root of x plus 1.
X plus 1. Square root of x plus 1 and over x minus 1. Did I change this here? X minus 1. Okay. Now can I cancel these?
Yeah.
Now, if you plug in 1 here, it's going to be the limit. There's no limit anymore. Going to be square root of 1 plus 1, which is going to be equal. I don't know. Is that easier when you evaluate? When you rationalize, sorry, then evaluate is going to be easy. We're going to multiply by square root of x plus 1. Be careful here. Square root of 1 plus x plus 1. You see on the top part, again, you have to now let's distribute this one here. 1 plus x times 1 plus x with the roots, so it's going to be 1 plus x. Don't forget the limit. So the limit, when x approaches 0, going to be 1 plus x. This one times 1 plus square root of 1 plus x. Negative 1 times going to be minus square root of 1 plus x, -1 times 1 minus 1. And here on the bottom, it's going to be x square root of 1 plus x, or you can keep it without distributing, it's going to be fine. This is cancel with this one. There's one positive, one negative. 1 minus 1.
0.
1 minus 1 is 0. So it's going to be the limit x approach to the 0, 0 divide by. Now, if you plug in 0 here and 0 here, it's going to be 0. So what does that mean? How are you going to check that?
Plug in numbers.
Plug in a number. Okay, pick a number here. No, don't look up. Plug in, pick a number here. 1, okay. Plug in the 1, okay. 1 plus 1,
2.
which is square root of 2. Okay, square root of 2 minus 1. Square root of 2, the main thing I care about the sign, right? It's a positive or negative. Square root of 2 is a positive number.
Positive.
Minus 1
Still a positive number.
is still a positive number, right? Okay. Divide by positive,
Still a positive.
still positive. That means 100% my function going up. Okay? Now, pick a number here.
-1.
-1. 1 minus 1. Square root of 0. Keep it as a 0, okay? Minus 1.
-1.
Divide by.
So
It's going to help. Pick another number.
2. -2.
-2, okay. 1 is going to be complex number. Because 1 minus 2 is going to be -1. It's going to be complex number. Pick what? Pick 0, -0.2. Go ahead and plug it. Because it's the asymptote.
Yeah.
It's the asymptote, that's why you have a gap. You see?
Yeah.
The function starts from which point?
Positive.
+1
Goes down negative.
and goes down like this.
Yeah.
And then like this from the other side or no?
I guess. Well, it doesn't go up. It just goes straight.
Straight, okay.
And it just jumps over the asymptote.
You got it now?
You got it.
Okay. That's mean I'm going to use this rule. But the rule says sine x. The rule says limit to sine x over x is equal 1. When x approaches to which number? To the 0.
0.
This is my rule. Now I have what?
You have 3.
3x. So what I'm going to do with it, this is 3x. Because the problem here is now what? Is number 3. Yes or no? Yes. Okay. Think about that. How are we gonna not cancel? Take 3 out. Think about that. Now let's go back again. Can I take the limit to the top and the limit to the bottom? I'm gonna do it as a math, okay? Because we have a rule that says the limit for f of x over g of x is going to be limit f of x over limit g of x. Yes or no?
Yes.
So can I use this one here? Yes, I'm gonna say, okay, this is equal the limit let's approach to the 0, the sine x over the limit when x approaches to the 0 to the 3x. I'm gonna go I'm doing that in details, okay? Then we're just gonna solve it right away because I need you to understand what I'm doing. I'm gonna keep the top part. Limit 3 times x. Can I use rule number 2? The multiplication between two functions is going to be the limit for the first one plus, times the limit for the second one. So that means here is the limit for sine x over limit 3 times limit to the x. Yes or no? Of course, x to the 0, and x to the 0, and x to the 0. Yes or no?
Yes.
What's the limit for the constant? First rule. What's the limit for the constant? Constant. So I'm gonna keep this one as x approaching the 0, sine x over, and here's limit to the x, and x approach to the 0, and this is 1 over 3. Yes or no? Yes or no?
Let's see. You're multiplying 1/3.
So now can you say, okay, it's 1 over 3, limit x approach to the 0, sine x over x. Yes or no? We're gonna bring this back. Sine x over x. Now how much here?
That's 1.
That's 1.
So it's 1 times 1/3. So the answer is 1/3.
1/3. But you're not gonna do all these steps. I'm just telling you, I'm using the same rules. Okay? So we're gonna go back to the first step. Every time when you see here, you're gonna say, okay, I'm just gonna take 1/3 out and put the limit for the rest. That means from here, you're gonna say, okay, I'm gonna say it's 1/3. If I took the 1/3 out, keep the limit, x approach to the 0, sine x over x is going to be what? 1/3 times 1 is going to be 1/3. You got it?
Got it.
But I'm using the same rules. Here's the steps. But that's how we're gonna solve it, okay? You got it?
Got it.
Again, if you have a question, just ask. How are we gonna think about that?
So we gotta get rid of the square.
Oh, because the square, be careful. The square is an angle. You can't take the angles from the side. Okay, you can't do anything, but can I add? Oh, not add. Like, can you make this x as an x squared? Yes or no?
Yes.
How?
By multiplying x.
By multiplying by x. So if you multiply by x, you have to divide by x.
What's 1/2?
So you're gonna multiply by what?
X. 1/1.
X over x. Because x over x is what?
Just 1.
Is 1. That's means I'm multiplying the whole thing by 1. So I'm not gonna change the value of limit sine x squared over x, because I'm multiplying the whole thing by 1, which is x over x. Okay? Now can I bring this x here?
Yes.
So it's gonna be limit x approach to the 0, sine x squared over x squared, but don't forget you have an x here. Let's put the x here, times x. Yes or no? Yes or no? Because the rule said sine x, this angle exactly the same x here. If it's x cubed, you have to get x cubed here. If it's x to the power 100, you have to get x to the power 100 here, so you can use the rule. Now, can I say it's the same thing, the limit, when x approaches the 0, sine x squared divided by x squared times the limit when x approaches the 0 to the x. Yes or no? How much this side?
That's one,
There's one. One times. How much this side?
X,
No,
what,
no.
what?
How much this part?
0.
Let's look this part. The second rule.
Yeah.
This is what we're gonna plug in. So the result is going to be piece of cake. Yes or no? It's the same rule. That's why I kept it here. Now I have sine square x. So what I'm going to do?
Times 1/2. Or, no, square root,
Oh,
no,
so think about that. On the previous example, we need to do this one squared. So we're gonna match the angle here, right? That's why we multiply. But think here, I have already x. The angle is already matched. What I'm gonna do?
you're trying to get to 1, or get rid of the square.
Oh, okay, how? Think about that. That's what I'm telling you. It's cool just to practice it. You have x squared. What I'm gonna do? You have sine. You have x squared. For example, can I write down x times x? Yes or no?
Oh, yeah,
Can I do the same thing here
yeah.
with the sine? So what I'm gonna do?
So you have the limit of sine x over x
X approach to 0. I'm
times,
gonna say it's a sine x times sine x over what?
2 over x.
Over x. Then I'm gonna say, okay, it's the limit from x approach to 0. Sine x over x times limit of sine x. For x approach to the, how much the result here? This is 1 times.
Sine x.
What's plug in this the 0? What's times 0? There is no rule. What's times 0?
0.
Can go back to yes. Got it? Get the idea? We can solve this example. So the tangent x is equal to sine x over cosine x. I'm gonna do this one here. This one is equal to the limit when x approaches to the 0, sine x over cosine x divided by x. What's the next step? Saying sine x divided by cosine x. Now sine x over sine x divide by x.
So we multiply 1 over x.
Perfect. That's mean you're gonna say it's the limit when x approaches to the 0, sine x over cosine x, because this is division. Change it to multiplication, multiply by the reciprocal of the bottom part, which is 1 over x. Now, can I switch these two?
What?
Can I switch these two?
Switch them?
Can I write down the x here and the cosine here? Yes or no?
Yeah.
If you have x times y, can you write down y times x?
Yes, yes.
Because it's commutative property. The multiplication has commutative property. You can switch it. It's fine. That means I can say, okay, it's the limit when x approaches to the 0, sine x over x times 1 over cosine x. Can I distribute the limit? It's multiplication. So it's the limit of x approach to the 0, sine x over x times the limit when x approach to the 0, 1 over cosine x. Is that cool? You don't know. How is the result here?
1.
1 times. How much the result here? There is no rule here. Plug in 0 here. Cosine 0 is what?
Yeah.
Cosine 0?
1 negative? No,
It's 1.
Yeah.
Sine 0 is 0. Cosine 0 is going to be 1 over 1. That's me. Got it? It's okay? Another example? Let's think about that.
So 10 becomes sine over cosine.
Okay.
You can cancel out cosine.
Okay. So perfect. Yeah, that's the important thing because tangent x equals sine x over cosine x. This is the rule.
Yeah.
So what I'm going to do, it's a limit. You know what I used to be doing before? When I was doing this example, I hate theta. I change it to x. And when I finish the example, I bring back the theta. I don't know why. Theta to the 0 cosine 3 theta times sine 3 theta over cosine 3 theta. And everything divided by theta. That means the cosine cancel. So what's the left?
Sine 3 theta over theta.
Theta to the 0 sine 3 theta over theta. Now what's the next step?
Now you get rid of the 3.
No, be careful. The 3 is an angle. 3 theta is an angle.
Oh, we got rid of it.
It's the same thing like here. It's the same thing like here. When we need an x here, we multiply by x over x. Now, where we need the number?
On the bottom.
Which is a 3. So it looks like you're multiplying by? No, 3 over 3. Remember we multiply by x over x? We put the x here and keep the limit with the second x. Okay? So now it's with the number. 3 over 3. You're going to bring this 3 here and keep the 3. So it's look like the limit.
Oh, I see.
X approach the 0 sine to the 3 theta over the 3 theta times what's the left here? 3. Take the limit for both. So is the limit x approach to the 0
It's 1.
sine 3 theta over 3 theta times limit when x approach to the 0 to the 3. Everything here is equal what?
1.
1 times the limit for constant.
3.
The result is going to be
3.
You got it? See, it's a little bit harder, but the same concept. So what about if I give you a homework? Full one. And then x approach 0 sine 5x over cosine 5x. You can't put 5x, let's put a 6x. Make it cooler. Sine 5x over cosine 6x.